The steps that we're going to follow, our first thing we have to do is isolate the radicals. So we're going to use our inverse operations to move everything except our root over to the opposite side of the equation. Then we will raise both sides of the equation to the power of the index. So if it's a square root, we're going to raise it to the second power. If it's a cube root, we'll raise it to the third, and so on. And then we're going to solve the remaining equations for x. When we find our solution, don't forget we have to check for extraneous solutions because we're dealing with square roots. We can't do the square root of a negative, so we just need to double check and make sure our answers work. So let's look at some examples. So on this first one, I see that my square root of x is on the same side as the plus 5. So we're going to subtract 5. Ooh, that is very, very big. Let's fix that. We will subtract 5 from both sides, which will give us the square root of x equals 7. And then I need to square both sides because this is the square root. And so remember, the inverse of that is squaring it. So the square root of x squared is just x, and then 7 squared is 49. Okay. And then we will take this solution and substitute it in and make sure it works. So my check is going to be the square root of 49 plus 5. This is 7 plus 5, which is 12. 12 is what I got on the right-hand side, so that works. Okay, on the next one, find your radical. That's the square root of 8x, and then we need to isolate it. So again, we're going to subtract 5 from both sides. Now this time it cancels on both, so I'm going to end up with the square root of 8x equals x. Okay, and now I have to get rid of the radical, so I'm going to square both sides. So then on the left side, I'm just left with 8x. On the right, I'm left with x squared. Now, this is where we're going to go back to factoring. So we're going to subtract 8x and then factor out an x, and we get x minus 8. So this is going to give us 2 factors, and we just set both of them equal to 0. So x equals 0 or x equals positive 8. Okay, and then we will check both of those. So the square root of 8 times 0 is 0. Plus 5 equals 0 plus 5. That works. The second one would be the square root of 8 times 8 plus 5, which is going to be 8 plus 5, which is 13. And the right side of the equation is also 8 plus 5, so that one also works. So both of these would be my solution. Actually, I'm going to write it as a single answer. So I would say x equals 0 or 8. You can leave it separate if you want to. Okay, on the next one, I have 2 radicals, and so one of them is already isolated. So I can go ahead and square both sides. On the left side, we're just left with x plus 9. On the right side, we're squaring a binomial. So remember, a squared minus 2ab minus or plus b squared. So the square root of x squared, okay, and then minus 2 times a times b plus b squared. So that would be 1 squared is 1. Okay, so this is actually going to end up being x minus 2 times the square root of x plus 1. We have x on both sides. Let me do that in a different color so we can see it. The x's on both sides are going to cancel. And then we're going to isolate this minus 2 square root of x. So we're going to subtract 1. So we get 8 equals negative 2 square root of x, and then we have to divide both sides by negative 2. So I get the square root of x equals a negative 4, which we know is not possible. So this would end up being no solution. Okay, the next one. Okay, remember your fraction exponents. The bottom is your index, so that tells us if it's a square root, a cubed root, a fourth root. The top number is your exponent for this quantity, whatever is inside the radical. So the first thing we're going to do is divide by -9, which will give us 4 equals. And then I am going to keep this in fraction form. You could also write it as a radical, but we need this to become a 1. That's essentially what we're doing in the other problems when we raise the square root to the second power. So for this one, if it's 1/2, we're going to have to multiply it by a squared or a power of 2. So we have to do that on both sides. So 16 is going to equal, these are going to cancel and become 1, c minus 12. So c is going to equal 28. And then we just need to plug it in and check and make sure it works. So we've got -9 times 28 minus 12 to the 1/2. So this is going to be 16 to the 1/2. I know that this is the square root, so that's going to be -9 times 4, which is -36, which is what we had on the other side. So that is a good answer. Okay, down below we have the fourth root, and we have it on both sides. So we are going to go ahead and raise, both of those to the fourth power. Okay, which will essentially cancel out, because remember this is like 1/4. So 1/4 times 1 is going to equal 1. Or 1/4 times 4, equals 1. So we're just left with what is inside the radical on both sides. Okay, so now we can add 2d to both sides, and we can add 3 to both sides, and we get that d equals 10. And then we'll do a quick check to make sure it works. So here we have the fourth root of 27 minus 2 times 10, which is the fourth root of 27 minus 20 is 7. On the right, we get the fourth root of 10 minus 3, which is also going to be the fourth root of 7. So since they are equal, that is a good answer. Okay, on the next one, first thing we need to do is isolate one of these radicals. So I'm going to divide both sides by 4. So that will give me the square root of 3x plus 15 on the left and 3 times the square root of x on the right. And then I have to square both sides. So that will give me 3x plus 15 on the left and 9x on the right. Subtract 3x from both sides and divide by 6. So 15 over 6 is going to be 5 over 2. And then we just need to check that and make sure it works. So we have 4 times the square root of 3 times 5/2 plus 15. So 3 times 5 is 15 over 2 plus 15, and this is going to be the equivalent of 30 over 2. So this is going to give me 45 over 2, and the square root of 45 is 9 times 5 over 2. So the square root of 9 is 3, so we can pull that out front, and we will get 12 times the square root, and then what we're left with in here is 5/2. Okay, and then if we take our 5/2 and plug it in up here, we'll see that we get 12 times the square root of 5/2, which is exactly the same thing. So that's a good solution.